design parameters that we considered when we laid out the organ, and that was that it would be laid out in such a way that we could bring groups of people through here as an educational process, and so this gives you the opportunity to see some of the inner workings of an organ that are usually the behind-the-scenes things. Of course, the organ is a wind-blown instrument. The source of that wind are there are about 500 young men in the basement. No, there are two very large blower devices in the basement that generate the pressurized air for this organ. Each of those blowers has a 5-horsepower electric motor on it, which is very large for an electric motor. Now the pressurized air is ducted through the floor and into this box that I'm standing on. This is the main air conveyance for the organ. You will see then all throughout where there are these brown lines tapped off of this box. Each one of these lines goes to one of these things. This is called a reservoir. There are 16 reservoirs in this organ. The reservoir has two functions. The first function is that it stores a large volume of pressurized air for use of the pipes above. And the second function is that it regulates the pressure. The pressure must remain constant at all times to any given pipe so that it sounds the same. A pipe is nothing more than a whistle. And you know what happens when you blow on a whistle. If you blow on it lightly, it sounds different than if you blow on it with excessive force. And so in order for these pipes to sound the same, the pressure has to be kept constant. The reservoir does that for us. From the reservoir, then once the air is regulated, it passes through another duct and into these boxes up above us. These are airtight boxes called wind chests. The wind chests contain all of the pneumatic valves that open and close that ultimately allow the air out through a hole that allow the pipe to speak. Now the way that valve is controlled, of course it starts with the organist. The organist plays a key and a pipe speaks. But what happens in between that basically happens right in here. Well, let's start at the console first. This organ is now controlled with two computers. One computer in the console and another computer right here in this cabinet. The computer in the console takes the information that the organist is giving it by pressing keys or manipulating the controls, and it converts it into data. That data is sent back to this computer where it is decoded, and the decoded signal then goes to several of these driver boards throughout this cabinet. These driver boards then send a 12-volt to very low voltage signal out through wires and up to, you will see these rectangular shaped things with little round caps on them. Those are all little electromagnets. So what happens is that electromagnet, once it receives a little signal, allows a valve to open only about a 64th of an inch. That causes an internal pneumatic to collapse, which then causes a chain reaction of other pneumatics inside here to open up, allowing the pressurized air that's inside there to go through the hole and play the pipe. It's actually not a very complicated procedure. Even though it sounds complicated and it looks complicated, It is actually very simple in its operation and a very effective means of playing an organ. Older organs, of course, were operated through a direct mechanical connection. There was no electric interface. However, this organ was among the first organs to implement an electrical interface from its console to the organ pipes. And what we've done is we've simply updated that electrical interface with a digital interface. Of course, this is not a digital organ. This is a pipe organ with a digital interface. Okay? As I mentioned,